James Webb has just detected there may be something watching us from deep space. At 03:17 a.m., something in deep space responded. No one was expecting a response. The James Webb Space Telescope was never designed to listen for answers. It was built to look back in time, to capture the faint glow of the first galaxies, to observe the quiet unfolding of a universe that should behave according to laws we understand. And yet, in a region so distant that its light began traveling toward us before Earth even existed, something changed. Not dramatically, not loudly, just enough. A signal shifted in a way that should not happen. A pattern appeared where randomness was expected. A flicker repeated with a precision that made scientists pause, then look again, then question what they were seeing. Because in the vast silence of space, repetition is not just unusual, it is suspicious. Imagine staring into an ocean so deep that no human has ever touched its floor. You send a pulse into the darkness, not expecting anything to come back. And then, after a delay that stretches across incomprehensible distance, the ocean answers. Not with a voice, not with a message, but with a rhythm. Something aligned, something responded. This is where the story begins. Not with aliens, not with conclusions, but with a disturbance. A subtle fracture in the assumption that the universe is indifferent. Because for the first time, the question is not just about what we can see out there, it is about whether something out there has begun to notice us. And if that thought feels distant, abstract, almost unreal, hold on to it. Because what the James Webb Space Telescope revealed next did not clarify the mystery, it deepened it. The eye that sees too far. The James Webb Space Telescope does not simply observe the universe. It reaches into its memory, into a time so distant that even the idea of Earth had not yet formed. When you look at the data it sends back, you are not witnessing what is happening now. You are witnessing what once happened, long before human eyes existed to notice it. Light, traveling for billions of years, finally arrives, carrying with it a story that was never meant to be heard this late. Suspended far beyond our atmosphere, protected from interference, this instrument was built with a clear purpose: to study the origins of galaxies, to map the early structure of the cosmos, to confirm what our models have long predicted about the birth of everything we see. It was designed to answer questions that have guided astronomy for generations. Questions about how matter came together, how light first emerged from darkness, how the universe transitioned from simplicity into the complex web we observe today. There is a quiet confidence in those expectations. The belief that the universe, no matter how vast, follows laws that are consistent, predictable, and ultimately understandable. The assumption that if we look far enough, clearly enough, patiently enough, we will see chaos gradually giving way to order. That is how structure forms. That is how galaxies are born. Slowly, randomly, shaped only by gravity and time. But the deeper the James Webb Space Telescope looks, the more that confidence begins to shift. Not collapse, not break, but bend. Because in certain regions, in certain observations, something feels out of place. The light is not behaving as expected. It is not scattered in the way early cosmic light should be. Instead, there are moments where it appears organized. Not perfectly, not continuously, but enough to stand out against the background of randomness that should dominate those distances. Imagine looking at static on an old screen, expecting only noise, only meaningless flicker. And then, within that noise, something repeats. A rhythm, a pattern that returns just often enough to make you wonder if it was ever noise to begin with. That is the tension now sitting inside the data. Not a clear message, not a signal anyone can translate. Just the uncomfortable presence of something that does not fully belong. The purpose of the James Webb Space Telescope was never to search for intelligence. That idea was always reserved for other methods, other instruments, other strategies. This telescope was meant to observe, to document, to confirm. It was meant to deepen our understanding of a universe that behaves according to known principles. It was not built to challenge the very framework those principles rest on. And yet, this is where the narrative begins to change. Because when an instrument designed to validate our understanding starts revealing details that resist simple explanation, something subtle happens. The conversation shifts, not publicly at first, but internally. Among those who analyze the data, who repeat the measurements, who check for errors and recalibrate their assumptions. There is a moment, quiet but undeniable, where certainty gives way to hesitation. That hesitation is not weakness. It is the beginning of discovery, because it forces a question that cannot be ignored. Why would regions of the early universe, governed by chaos, display traces of coherence that feel almost deliberate? Why would light, traveling from a time before structure should fully exist, carry hints of alignment that resemble intention more than randomness? No one is claiming answers. No one is declaring conclusions. But the presence of the question alone is enough to change everything. Because once you allow for the possibility that something unexpected is there, you can no longer look at the data the same way. Every pattern becomes significant. Every repetition becomes a signal worth examining. And this is where the tension deepens. Because what the James Webb Space Telescope is revealing is not loud. It does not announce itself. It does not demand attention. It simply exists, quietly embedded in the fabric of the observations, waiting to be noticed by those willing to look long enough. And now that it has been noticed, the question is no longer whether the universe is behaving as expected. The question is what happens when it does not. The anomaly. What first appeared in the data was not extraordinary at a glance. No dramatic signal, no unmistakable signature. Just a subtle inconsistency, buried within layers of observation, the kind of detail that would normally be filtered out as noise or dismissed as a temporary fluctuation. But this one did not disappear. It repeated, not in a way that immediately reveals intent, not in a pattern simple enough to decode at first sight, but with a persistence that challenges coincidence. A fluctuation in light intensity that returned after irregular intervals. A spectral shift that aligned too closely with previous measurements. A faint structure embedded within the signal that seemed to echo itself across time. The kind of thing that forces a second look, then a third, then a silence in the room as the data is run again. Because in deep space observation, randomness is expected. The early universe especially is a turbulent environment. Energy fluctuates, matter collides, light bends, scatters, stretches. Irregularity is the rule, not the exception. That is what makes these observations so difficult to interpret, and also what makes true anomalies so rare. But this was not behaving like chaos. There was a suggestion of order. Not perfect, not obvious, but enough to create tension between what is known and what is being seen. A kind of alignment that feels misplaced, as if something within the data is following a rule that has not yet been identified. Imagine standing in a forest where every sound blends into a natural rhythm. Wind through leaves, distant movement, the quiet language of an environment that has its own logic. And then, within that rhythm, you hear something that does not belong. Not loud enough to alarm you immediately, but precise enough to separate itself from everything else. You listen again, and there it is, repeating just enough to make you question whether it was ever accidental. That is the position now. Not certainty, not conclusion, but a growing awareness that something is present in the data that refuses to be reduced to randomness. And this is where the challenge begins, because the moment you identify a potential pattern, you must prove that it is not an illusion. Every instrument has limits. Every observation carries the risk of error. Distortion can come from calibration issues, background interference, or even the way signals are processed and interpreted. The first instinct is always skepticism. Assume the simplest explanation, look for flaws in the system, question the validity of the measurement, and that is exactly what happened. The data was reprocessed, the parameters were adjusted, independent analyses were conducted. Known sources of interference were examined and eliminated one by one, and still the anomaly remained. Not identical in every instance, not perfectly stable, but present enough to resist dismissal. This is where discomfort begins to grow, because science depends on patterns. It depends on the ability to observe, repeat, and explain. When something repeats without fitting into an existing framework, it does not immediately become extraordinary. It becomes a problem, a gap in understanding that demands resolution. But what if the resolution does not come easily? What if the pattern is real, but the explanation is not yet within reach? This is the threshold where observation transforms into something else, something quieter, more unsettling. Because now the question is no longer whether the anomaly exists. The question is what it represents. And that question leads directly into the next layer of this discovery, where expectation and reality begin to separate in a way that cannot be ignored. What science expected. Before this anomaly entered the conversation, the expectation was clear, stable, and grounded in decades of observation. The early universe was not supposed to be organized. It was not supposed to behave with precision or exhibit coherence beyond what gravity and basic physical laws could gradually impose over immense spans of time. In its infancy, the cosmos was a restless field of energy, expanding, cooling, colliding with itself in ways that produced complexity only through chaos. When the James Webb Space Telescope looks deep into space, it is essentially looking into that infancy. It captures photons that began their journey billions of years ago, carrying information from a time when structure was still fragile, when galaxies were only beginning to assemble, when randomness dominated every observable scale. The expectation is not perfection, it is noise, variation, irregularity that slowly gives way to recognizable forms. In that context, patterns should be rare, and when they appear, they should be explainable through known mechanisms. Gravitational clustering, thermal fluctuations, the distribution of dark matter. These forces shape the universe in predictable ways. They do not create precise repetition. They do not generate signals that return with a consistency that invites interpretation beyond physics. This is what makes the current observations so difficult to place. Because the anomaly does not fully align with chaos, but it also does not clearly fit within any known structure-forming process. It exists in a kind of boundary space, where expectation begins to lose its authority. Not completely, not decisively, but enough to create tension between theory and observation. Imagine studying waves on the surface of an ocean. You understand how wind, pressure, and currents shape their movement. You can predict their behavior within a range of probabilities. But then, in the middle of that fluid motion, a sequence of waves begins to rise and fall in a repeating pattern that does not match the conditions around it. Not perfectly synchronized, but consistent enough to stand apart. Your first instinct is not to assume something extraordinary. It is to question your model, to re-examine the variables, to search for hidden influences that might explain what you are seeing. That is the discipline of science. It resists premature conclusions. It demands evidence, replication, and clarity. And that process is unfolding here. Researchers are not rushing to define the anomaly as anything beyond an unresolved observation. They are testing it against known phenomena. Could it be an unknown type of stellar behavior? A new form of interaction between matter and radiation? A distortion introduced by gravitational lensing on an unexpected scale? Each possibility is explored carefully, systematically, without assumption. But there is a subtle shift happening beneath that process. Because every explanation that fails to fully account for the pattern leaves behind a residue of uncertainty, and that uncertainty accumulates. It does not point directly to a conclusion, but it opens a space where new questions begin to form. Questions that were not necessary before, because the framework seemed complete. Now, that framework is being tested. Not broken, not discarded, but stretched to accommodate something that does not easily fit inside it. And when a model of the universe begins to stretch, it reveals its limits. It shows where understanding ends and possibility begins. This is the moment where science stands at a threshold, not between knowledge and ignorance, but between explanation and curiosity. Because the more clearly we define what should be happening, the more striking it becomes when something does not follow that path, and what follows from that realization is not an answer. It is a deeper question. Because if the universe at its earliest stages is capable of producing patterns that resemble intention more than randomness, then the line between natural process and something more complex becomes harder to draw. And that leads directly to the next layer of this unfolding discovery, where the idea of pattern itself becomes impossible to ignore. The pattern that should not exist. At some point, repetition stops being coincidence. That is the line scientists are trained to recognize, the moment where randomness can no longer carry the weight of explanation. Because in a universe governed by probability, patterns do emerge, but they dissolve just as quickly. They do not hold. They do not return with consistency. They do not invite recognition. And yet, within the data captured by the James Webb Space Telescope, something has begun to hold. Not perfectly, not with mechanical precision, but with enough persistence to resist dismissal. Signals that rise and fall in intervals that echo previous observations. Variations in light that align across distances where alignment should be statistically insignificant. Structures that appear, disappear, and then reappear again with a familiarity that feels almost deliberate. This is where the conversation shifts from anomaly to pattern, and pattern changes everything. because a pattern suggests constraint. It suggests that something is following a rule, even if that rule is not yet understood. In physics, rules are everything. They define behavior. They allow prediction. They turn observation into knowledge. But when a rule is implied without being known, it creates a gap that cannot be ignored. Imagine watching a sequence of events that should be entirely random. Points of light flickering in no particular order. And then, slowly, you begin to notice that certain flickers return at intervals. Not exact, but close enough to form a rhythm. You try to dismiss it. You assume your perception is imposing structure where none exists. But the more you observe, the more the rhythm persists. At that point, the question is no longer whether you are seeing a pattern. The question is why it is there. In deep space, far beyond the influence of local interactions, patterns are rare. The forces at play are vast, diffuse, and governed by initial conditions that favor irregularity. For something to repeat across such scales, there must be a mechanism, a process that enforces that repetition, that sustains it across time and distance. So, what could that mechanism be? The first answers remain grounded in physics: unknown oscillations in cosmic structures, interactions between forms of matter we do not fully understand, subtle effects of gravitational distortion that create illusions of repetition. These are the explanations that maintain continuity with what is already known. But there is a limit to how far those explanations can stretch, because the more the pattern holds, the more it begins to resemble something else. Not a natural fluctuation, but a form of organization. Not chaos shaped by time, but structure appearing where time has not yet had the chance to shape it. And this is where discomfort begins to take form, because organization implies information. It implies that something is being arranged according to a principle, and information, by its nature, carries meaning, even if that meaning is not yet accessible. In every domain we understand, from biology to technology, patterns that persist are not accidents. They are the result of processes that encode, transmit, or preserve something. That does not mean intelligence, not yet. That leap is too large, too unsupported. But it does mean that the boundary between random and non-random behavior is being tested in a way that cannot be easily resolved. And once that boundary is questioned, everything that depends on it becomes uncertain. Because if a pattern exists where none should, then either our understanding of the environment is incomplete, or something within that environment is operating according to principles we have not yet identified. Both possibilities are profound. One expands physics. The other reshapes perspective. And it is at this intersection, where pattern meets uncertainty, that a quieter question begins to emerge. Not spoken directly, not confirmed, but present in the background of every analysis. What if this is not just a pattern, but the trace of something responding? The silent possibility. There is a moment in every discovery when the data stops being just data. It becomes a question. Not a question that can be answered immediately, not one that fits neatly into equations or models, but one that lingers. A presence in the background of thought, quiet but persistent, reshaping the way everything is interpreted from that point forward. That moment has arrived, because once a pattern is recognized, once repetition holds long enough to resist dismissal, the mind begins to explore possibilities it would normally reject. Not out of belief, but out of necessity. When known explanations fail to fully contain an observation, the space of inquiry expands, and within that space, a single idea begins to take form. What if this is not just a signal, but a response? The question is subtle, almost fragile, because it challenges a deeply rooted assumption that the universe is passive, that it unfolds without awareness, without intention, without any form of recognition of what exists within it. This assumption has guided exploration for centuries. It allows observation to remain neutral, detached, grounded in the belief that we are looking at something that does not look back. But what happens when that assumption begins to shift? Not collapse, not disappear, but bend just enough to allow another possibility to exist alongside it. A possibility that does not replace science, but extends the range of what science must consider. Imagine sending a signal into the unknown, not expecting anything, not even imagining that something could answer. And then, after an interval that stretches beyond comprehension, something changes in the environment you were observing. Not clearly linked, not undeniably connected, but timed in a way that invites attention. You hesitate, because the first instinct is to reject the connection, to separate cause and effect, to protect the integrity of the model that says the universe does not respond to us, that what we observe is independent, unaffected by our presence. And yet, the timing remains, the pattern persists, the question returns. What if there is a relationship between what is sent and what is seen? This is where caution becomes essential, because the human mind is built to find meaning, even where none exists. It connects points, constructs narratives, imposes structure. That is why skepticism is not just important, it is necessary. Every potential link must be tested, every assumption challenged, every coincidence examined until it either dissolves or strengthens. And still, the possibility remains. Not confirmed, not proven, but present. A silent possibility. Because if the anomaly is not random, if the pattern is not accidental, if the repetition is not a byproduct of unknown natural processes, then something else must be considered. Something that does not yet have a place within our current understanding, but cannot be excluded simply because it feels unfamiliar. This is not the point where conclusions are drawn. This is the point where awareness shifts, because the question itself changes the observer. It introduces a layer of uncertainty that cannot be removed. From this moment on, every piece of data carries an additional weight. Every pattern is examined not only for what it is, but for what it could represent. And that changes everything. Because the universe is no longer just a field of observation. It becomes a space of potential interaction. And if that idea feels distant, almost impossible, consider what it implies on a more personal level, not in terms of galaxies or signals, but in terms of presence. Because if something out there is capable of responding, even in ways we do not yet understand, then the distance between observer and observed is no longer absolute. It becomes a connection. And that connection leads directly to the next realization, where the scale of this possibility begins to move closer, away from abstraction, towards something that touches every human being who has ever looked up at the night sky. Why this changes everything. Until now, everything has remained distant. Galaxies, signals, patterns, anomalies, concepts that live far beyond human scale, far removed from daily life, safely contained within the idea that whatever is happening out there does not affect what happens here. That distance has always been our comfort. It allows the universe to remain vast without becoming personal. But that distance begins to collapse the moment you consider a simple possibility. What if we have never been hidden? For more than a century, humanity has been sending signals into space. Radio waves, radar pulses, transmissions that carry fragments of our presence outward at the speed of light. Every broadcast, every communication, every attempt to reach beyond our world expands a sphere around Earth, a growing shell of information that continues to move through the cosmos. We rarely think about it, because the assumption has always been the same. Space is too large, the signals are too weak. The chance of anything receiving them is so small that it can be ignored. It becomes a theoretical concern, not a real one. But now, place that assumption next to what is being observed. A pattern that should not exist, a repetition that resists randomness, a timing that invites questions. And suddenly, the idea of isolation no longer feels certain. Because if something out there is capable of detecting, interpreting, or even reacting to signals across vast distances, then the boundary we believed separated us from the rest of the universe may not be as absolute as we imagined. It may be permeable. It may have always been open. This is where the shift becomes personal. Not in a dramatic way, not in a way that demands fear or immediate conclusion, but in a quiet, unsettling recognition that every signal humanity has ever released into the cosmos is still traveling, still expanding, still announcing in the simplest possible form that we exist. We have been speaking into the darkness for decades. The question now is whether the darkness was ever empty. Imagine standing alone in a vast, silent landscape, convinced that no one else is there. You speak, not expecting an answer, not even considering that your voice could be heard. And then, somewhere far beyond your field of vision, something shifts. Not a clear reply, not a recognizable voice, but a change in the environment that occurs after you speak. You would hesitate. You would listen more carefully. Because the possibility of being heard transforms everything about what it means to speak. This is the transformation now unfolding at a cosmic scale. Because if the anomaly is not random, if the pattern is not accidental, then the idea that we are unnoticed becomes harder to defend. Not impossible, not disproven, but weakened. And in that weakness, a new awareness begins to emerge. We are not just observers of the universe, we are participants within it. And participation carries consequences, not necessarily danger, not necessarily contact, but exposure. The realization that existence itself is a signal. That presence is not something that can be hidden simply by distance. That the act of being here, of emitting energy, of interacting with the environment, leaves traces that extend far beyond what we can perceive. This does not mean that something is watching, but it does mean that the possibility of being observable is real. And once that possibility is acknowledged, it cannot be undone. Because every future observation, every new piece of data, will now be interpreted through a different lens. A lens that includes not just what we see, but what might see us in return. And that is where the need for caution returns. Because before any conclusion can be approached, the foundation must be tested. Every anomaly must face scrutiny. Every pattern must be challenged. Every possibility must be filtered through the discipline that has brought us this far. Which leads directly into the next step, where skepticism becomes not just a tool, but a necessity. The filter of skepticism. Before any extraordinary idea is allowed to take shape, it must pass through resistance. Not emotional resistance, not fear, but discipline. The kind that defines science at its core. Because every anomaly, no matter how intriguing, begins as a problem to be solved, not a mystery to be celebrated. The first response is not wonder, it is doubt. And that doubt is deliberate. When the data from the James Webb Space Telescope revealed patterns that seemed to defy expectation, the immediate reaction was not to interpret them as something meaningful. It was to break them apart, to question the instruments, the calibration, the processing methods, to assume, first and always, that the simplest explanation is the correct one. Because instruments can fail, sensors can drift, algorithms can introduce artifacts, signals can be distorted by interference that is subtle enough to pass unnoticed at first. Even the vastness of space itself can bend and reshape light in ways that create illusions, patterns that appear structured, but are in fact the result of complex interactions we already understand. So the process begins. Data is reanalyzed from the ground up. Independent teams review the same observations using different methods. Known sources of error are systematically eliminated. Background radiation is accounted for. External influences are modeled and removed. Every step is designed to strip the anomaly of its mystery, to reduce it to something ordinary. And often, that is exactly what happens. Patterns dissolve, signals flatten. What once seemed extraordinary returns to the realm of the explainable. This is how progress is made, by refusing to accept the extraordinary until the ordinary has been exhausted. But this time, something remains. Not unchanged, not perfectly preserved, but present enough to resist complete explanation. The anomaly shifts under scrutiny, adapts as variables are adjusted, yet does not disappear entirely. It survives the process that is meant to eliminate it. And that survival creates tension, because skepticism is not meant to confirm mystery. It is meant to remove it. When something endures beyond that process, it does not immediately become significant. It becomes unresolved. A question that has not yet found its answer within the boundaries of current understanding. This is where caution intensifies, because the human mind is not neutral. It seeks patterns, it builds narratives, it connects events that may not be connected. This tendency has led to discovery, but it has also led to error. That is why skepticism must remain stronger than curiosity, at least in the early stages of any investigation. Every possibility must be tested against what is already known. Could this be a rare but natural cosmic phenomenon that has not yet been fully documented? Could it be an interaction between forms of matter that behave differently under extreme conditions? Could it be a statistical anomaly that appears meaningful only because it has been observed at the right moment? Each question is explored with precision, and yet, the deeper the analysis goes, the more a subtle realization begins to take hold. Not a conclusion, not a declaration, but an awareness that the anomaly is not easily absorbed into existing frameworks. It does not vanish under scrutiny. It persists at the edges of explanation, where certainty begins to thin. This is not a failure of science. It is its function. Because science does not exist to confirm what is already known. It exists to confront what is not yet understood, to push against the limits of explanation until those limits expand. And that expansion is uncomfortable. It requires accepting that not everything can be immediately explained, that some observations will remain suspended between possibility and understanding, waiting for new ideas, new models, new ways of seeing. This is one of those moments where skepticism has done its work, where doubt has been applied with rigor, and where the anomaly still stands, not as proof of anything beyond physics, but as a signal that something within physics may be incomplete. And when incompleteness appears at this scale, it opens the door to deeper questions. Questions that do not just ask what is happening, but why the universe would allow such patterns to exist at all. Which leads to the next layer of this unfolding story, where the silence of the cosmos itself begins to feel less certain than it once did. The cosmic paradox. For decades, one question has followed every attempt to understand our place in the universe. If life is possible, if intelligence can emerge, if the cosmos is as vast and as old as we know it to be, then where is everyone? This is the essence of the Fermi paradox, a contradiction that has never been fully resolved. Because statistically, the universe should be filled with signals, with traces, with evidence that we are not the only observers looking into the dark. And yet, until now, the overwhelming experience has been silence, a silence so complete that it shaped our expectations. We learned to accept it, to interpret it as absence, to build entire frameworks around the idea that, for reasons unknown, intelligent life is either rare, distant, or deliberately quiet. The paradox became part of the background of scientific thought, a question without urgency, a mystery that could remain unanswered without consequence. But what happens when that silence begins to fracture? Not break completely, not reveal itself in a way that provides immediate clarity, but shift just enough to suggest that it may not have been absolute, that what we interpreted as emptiness might have been something else entirely, something subtle, something difficult to detect, something that does not announce itself in ways we expected. The anomaly now under observation does not resolve the paradox, it complicates it, because it introduces a possibility that sits between presence and absence, a possibility that the universe is not silent, but simply not speaking in a language we have learned to recognize. That signals may exist, patterns may form, structures may emerge, but in ways that blend into the background of cosmic noise unless observed with the right tools, at the right moment, with the right perspective. Imagine standing in a crowded room where everyone is speaking in frequencies just beyond your range of hearing. To you, it feels silent, empty, devoid of communication. But the silence is not real. It is a limitation of perception. Now extend that idea to the scale of the universe. What if the apparent silence is not the absence of activity, but the result of our current inability to interpret what is already there? This is where the paradox deepens. Because if the anomaly represents a form of pattern that does not align with known natural processes, yet also does not clearly declare itself as artificial, it occupies a space that challenges the binary thinking we have relied on. It is neither clearly random nor clearly intentional. It exists in between, and that space is difficult to navigate because it forces a reconsideration of the question itself, not where is everyone, but what have we been missing? Not why is there no signal, but what if the signal has never been obvious? This shift does not provide comfort. It introduces uncertainty at a deeper level. Because if the universe is capable of producing patterns that resemble communication without being immediately identifiable as such, then the distinction between natural and artificial becomes less clear. It becomes a spectrum, not a boundary. And somewhere along that spectrum, there may be phenomena that we do not yet have the tools to classify. That is where the anomaly now resides. Not as proof of intelligence, not as confirmation of anything beyond physics, but as a reminder that our understanding of what constitutes a signal may be incomplete, that our expectations, shaped by human concepts of communication, may not apply to processes that operate on entirely different scales, under entirely different conditions. And once that realization takes hold, the silence of the universe no longer feels reassuring. It feels unresolved. Because the absence of clear evidence is no longer the same as the absence of activity. It becomes a question of interpretation, of perception, of whether we are equipped to recognize what we are observing. This is the paradox in its evolving form. A universe that appears quiet, yet contains patterns that suggest otherwise. A cosmos that does not speak in ways we understand, yet may still be expressing something beyond randomness. And as this realization begins to settle, something changes in the way the anomaly is perceived, because it is no longer just a pattern to be analyzed. It becomes a moment to be reconsidered. A moment where the observer is no longer separate from the observation, but part of a larger context that may include more than we have ever allowed ourselves to imagine. The moment of realization. There is a point where the data stops changing, but your perception of it does. Nothing new appears, no additional signal, no clearer pattern, no sudden breakthrough that resolves the anomaly into something definitive. The same information remains on the screen, unchanged, stable, waiting. And yet, something shifts, not in the universe, in the observer. Because once you have considered the possibility that the pattern is not entirely random, once you have allowed for the idea that the silence may not be complete, you can no longer return to the previous state of certainty. The data is no longer neutral. It carries weight. It invites interpretation at a level that did not exist before. The James Webb Space Telescope did not change what it captured. It changed how we look at what was captured. And that difference is profound, because now every repetition feels intentional, even if it is not. Every alignment feels meaningful, even if it emerges from unknown natural processes. The boundary between observation and interpretation becomes thinner, more fragile, more difficult to maintain with absolute clarity. This is not a flaw, it is a transition. The moment when science approaches the edge of its current understanding and must decide how to move forward, whether to hold firmly to existing models and wait for more data, or to allow new questions to reshape the way those models are constructed. And within that decision, something subtle emerges, a realization that is not spoken directly, not confirmed by evidence, but felt in the way the anomaly is approached. A recognition that the universe may not be as indifferent as it once seemed. That observation itself may carry implications we have not fully explored. Imagine looking into a mirror, expecting only your own reflection. And then, for a fraction of a moment, something in that reflection appears to move independently. Not enough to confirm, not enough to prove, but enough to create doubt. You look again. The image is the same, but your certainty is not. That is where we are now. The anomaly has not declared itself. It has not revealed its nature. It has not crossed the threshold into something that can be defined or categorized. It remains exactly what it was at the beginning, and yet it feels different, because the context around it has changed, the questions have evolved, the framework used to interpret it has expanded, and in that expansion, the possibility space has grown wider than it has ever been. This is the moment where the observer becomes part of the equation, not in a physical sense, not in a way that alters the data, but in a conceptual sense. The act of observing is no longer passive. It carries awareness. It carries the understanding that what is being seen may have layers that extend beyond immediate explanation, and that awareness cannot be reversed. Because once you consider that the universe might contain patterns that challenge the boundary between randomness and meaning, you begin to see those patterns everywhere, not because they are necessarily there, but because the mind has learned to look for them. This is the power and the risk of realization. It expands perception, but it also demands discipline. It requires constant balance between curiosity and skepticism, between openness and rigor. Because without that balance, interpretation can drift into assumption, and assumption can lead away from truth. But when that balance is maintained, something remarkable happens. The unknown does not become threatening, it becomes compelling. And that is where the story reaches its most delicate point. Because the anomaly is still there, unchanged, unresolved, waiting. But the way we understand its presence has transformed. It is no longer just something we detected. It is something we are now trying to comprehend from within a universe that may be more complex, more layered, and more responsive than we ever imagined. And that leads to the final step, where the question is no longer about what we found, but about what it means to have found it at all. The open ending, the data remains, unchanged, unresolved, still resting at the edge of explanation where certainty cannot fully reach. No final answer has emerged, no confirmation has been declared. The anomaly continues to exist in that narrow space between what we can describe and what we can understand. And yet, something irreversible has already happened. Because once a possibility enters the conversation, it cannot be removed. It lingers, shaping every future observation, every interpretation, every question that follows. The universe has not spoken clearly, but it has shifted just enough to ensure that silence will never feel the same again. The James Webb Space Telescope did exactly what it was built to do. It observed, it recorded, it revealed. But in doing so, it may have opened a door that was never meant to be noticed so early. A door not to answers, but to awareness. We now stand in a different position than we did before, not because we know more, but because we are asking different questions. Questions that extend beyond physics, beyond observation, into the nature of presence itself. What it means to exist in a universe that may not be entirely indifferent. What it means to emit signals into a space that might not be empty. What it means to look outward and consider, even for a moment, that something might look back. This is not a conclusion, it is a shift. Because the most profound discoveries are not always the ones that provide answers. They are the ones that change the direction of thought. The ones that alter the way reality is perceived, even when the underlying facts remain incomplete. The anomaly does not prove that something is watching. It does not confirm that a response was received. It does not redefine the universe in a single moment of revelation. But it does something more subtle. It introduces doubt into certainty. And doubt, when guided by discipline, becomes the foundation of deeper understanding. So the question remains. Not resolved, not finalized, but present. We pointed an instrument into the deepest darkness we could reach, into a region of space so distant that it exists at the very limits of what can be observed. We expected silence, randomness, the quiet unfolding of a universe that does not notice itself. And instead, we found something that does not fully behave that way, something that repeats, something that aligns, something that resists simple explanation. The question is no longer whether the universe is vast. We already know that. The question is whether that vastness includes forms of structure, of pattern, of presence that we are only beginning to recognize. Because if it does, then every observation becomes more than a measurement. It becomes a step closer to understanding a reality that may be far more complex than we have allowed ourselves to imagine. And if there is even a small chance that what we are seeing is not entirely random, then the silence we thought we understood was never silence at all. It was something we had not yet learned how to hear.